The simulation of inverting an amplifier and non-inverting amplifier. Learning outcome of the session. At the end of the session, students will be able to add the LM741 op-amp mod file into the LT Spice and simulate the inverting amplifier and non-inverting amplifier. So, before proceeding, let me ask you one question. What are the different applications of operational amplifier? You may pause the video, think about the question and write down your answer in your notebook. And after writing the answer, you can resume the video to see the answer. Now, let me give you the answer. The basic applications of the operational amplifier can be phase shifter, summing amplifier, differential amplifier and integrator. So, let us see what is an inverting amplifier. So, inverting amplifier is a type of the operational amplifier circuit which produces an output which is out of phase with respect to the input by 180 degree. So, here we apply the input signal to the inverting terminal of the op-amp via the resistor R1 and we connect the non-inverting terminal to the ground. So, the output is amplified and it is phase shifted by 180 degree in this way. Further, we provide the feedback necessary to stabilize the circuit and hence to control the output through the feedback resistor R2. The voltage gain of the inverting operational amplifier is given by voltage gain A is equal to minus R2 by R1. So, let us see the non-inverting amplifier. As name implies, the non-inverting amplifier is one of the circuit in which the output is in phase with respect to the input. Thus, this is the input signal. If sinusoidal is applied to the input of the non-inverting amplifier, the output will be amplification of the input which is in phase with the input signal. So, the output will look like this. So, the input is now applied at the non-inverting terminal of the op-amp. The output is non-inverted amplifier version of the input. So, the feedback is applied at the inverting terminal. So, the voltage gain of the non-inverting operational amplifier is given by voltage gain A is equal to 1 plus R2 by R1. Now, let us see how to simulate the circuit in LT Spice software. Now, this is the LT Spice environment. If you go to the component and if you search for LM741, you will find that there is no library available. So, what to do? So, go to the website texasinstrument.com product /LM741 and there you will find a simulation model which is written by LM741 P-Spice simulation model. So, download that. When you download it, you will see there is one zip file is downloaded. So, unzip that file and the content of that file you can copy to the directory where you want to copy that. So, I have already copied that file into the my directory E drive. So, here I have copied the file. Now, go to the LT Spice software, go to the file and click on open and then open the downloaded file. Go to here and select all files. Here you can see the LM741 mod file. So, open that. As you can see the description of the file. So, what we need here, this component name is needed. So, copy that name and now you can close the file. Now, go to the component and there go to the op-amps and then go for the op-amp 2 and click on OK and add that particular component. And after that, right click over that component, you can see here the value. So, rename that and paste the value or give the name to the value which we have already copied from the mod file, that is LM741/NS and click on OK. Now, we have given the component name by the mod file. Now, how to include that mod file in the LT Spice directory, let us see. There is one option which is written by Spice directory, click on that option. Now, write the command .include then space. Now, what we will need? We will need the location. So, where is that location? So, it is located on E drive. So, E drive, what is the name of that file? LM741.mod. Give the extension also and click on OK. So, I will include it here. Now, first we will build the schematic of the inverting amplifier. So, for that first we will add the voltage source. So where is the voltage source? So here you can see the voltage source. So I will add the two voltage source, one by rotating another. Then connect the terminals by the wires, and then I will add the ground. Now for this I will use the label for this terminal and this terminal. So here you can see the label, click on that and say give the value. You can select the output as port type as output, give the value as V plus and click on OK and connect it here. Next again go to the label, select the type as output and give the name as a V minus and connect it here. So we have created the supply for this inverting amplifier. So now what I am going to do, I am going to rotate this component. So first in order to mirror that, press Ctrl E, and in order to rotate, Ctrl R. So it will be easy for the drawing the circuit. Now let us what we will do. Now let us add the resistor at the input. Press Ctrl R to rotate. So at the inverting terminal we will add the resistor R1. Then at the output we will add the resistor R2, and at the feedback we will add the resistor R3. Now connect the resistors by using the wires. So this is the feedback resistor. The non-inverting terminal of the op-amp will be grounded. So let us connect it to the ground. Now we will give the supply. Just to copy this symbol, go to the copy option. Here you can see the copy option. Click on that, copy that terminal and connect it to the negative supply of the op-amp, and then copy this and connect it to the positive supply. Now let us add the voltage source at the input. Go to the component and select the voltage and add the input and connect it by the using wire. Now we will add the ground at the input as well as the output. So here is a complete schematic diagram of the inverting amplifier, okay, using op-amp. Now go to this supply option, right click on that option and then click advance. So here you can see this voltage source, you can see the sine voltage source. So DC offset, let us give it as 0. Amplitude of the sine wave we will give it as 500 millivolt. Let us give the frequency of 50 hertz. Click on OK. Now we have completed the circuit diagram. Now we have to simulate this circuit. So go to the simulate option and click on edit simulation command. Here stop time of the simulation, let us give it as a 100 millisecond. Now let us give the values to the resistor. Okay, right click over this resistor and give the value as 1K. For this give the value as 10K, and for this give the value as 1K. Let us give the value to the voltage source. Right click over that, give 12. Also here give 12. So we have connected the 12 volt DC supply. We have used the sine wave as input with the 500 millivolt peak to peak amplitude and 50 hertz frequency. Now go to the option run. So in order to first let us observe the input waveform. So here you can see the input signal. Now let us observe the output waveform. So here is the output waveform. As you can see that the blue curve represents the output and green is representing the input. As you can see that the output is amplified version of the input signal and it is 180 degree out of phase with respect to the input signal. And how the gain is calculated? The gain of the op-amp is calculated by using minus R2 by R1, that is 10 by 1. So what will be the gain? The gain of this op-amp will be 10. So as you have given the 500 millivolt as an input, the output amplified to the 5 volt peak to peak. In this way, we have simulated the inverting operational amplifier circuit. Now, let us simulate the non-inverting operational amplifier circuit. Now, what changes we have to do in this schematic? So, just we have to change the terminals. Okay. So, first we will cut the wires. Now, what we have to do? We have to give the input to this non-inverting terminal. So, we will move this resistor R1 to here and then connect this to the terminal of the input, positive terminal of the input. Now, what we need? We will need another resistor at the inverting terminal and then connect it by using the wires, and this will act as a feedback. And remaining ground we will connect it here. Give the value to the new resistor as 1K. Now, everything will remain unchanged. So, this circuit will act as a non-inverting amplifier circuit. So, let us simulate that. Go to the option run. So, this is the input and let us observe the output. So, this is the output. The blue waveform is the output and the green is the input. So, the output is in phase with the input signal and it is the amplified version of the input signal. These are the references of the session. Thank you.